Okay, welcome. Thank you very much for joining us for this live stream today. I'm delighted to be joined by Bill Higgins. My name is Barry O'Reilly, and this has really been a sort of fun collaboration in many ways. Myself and Bill have known each other for many years, and over that time, we've had and looked for many ways that we can collaborate on something. And a few months ago, a great idea sort of struck us. I had just published my book Unlearn, Let Go, Past Success, and Bill was taking a more and more active role in machine learning and Watson at IBM. So we thought about, well, what could we teach people about machine learning and what need to be unlearned? And as if by epiphany, Bill was like, well, let's just write about machine unlearning. So here we are to sort of share our sort of journey with you, the twists and turns that we've taken over the last sort of months on our journey to both explore machine learning, but what needs to be unlearned to make the most of that. So with that, Bill, well, welcome to the show, and maybe you can tell people a little bit about what your current focus at IBM is.
Yeah, my current focus is a couple things. So if folks are familiar with our Watson technology, it first premiered about 10 years ago in February 2011 by winning Jeopardy. And since then, we've been evolving it to make it more useful for enterprises. And so these days, I'm responsible for the evolution of the Watson core technology, which becomes part of IBM products, it becomes part of partner products, and it becomes part of customer applications. Because what we're trying to do is take AI kind of out of the research lab and actually infuse it into enterprise products and enterprise applications, because it can lead to really transformative experiences and capabilities that you simply can't do with traditional programming.
Yeah, fantastic, right? So what we're going to cover really is what needs to be unlearned about machine learning when, especially trying to take it to product development. What's different, how you get started, and at the end, we'll give you sort of our recommendations about where you can get started on your own journey. So don't forget to subscribe to the channel, and we'll sort of share some of the lessons we've learned. So starting there, one of the first one, really the sort of big sort of misnomer that really we need to start thinking about, especially when building machine learning models, is the first thing you need to start thinking about is not building, it's actually learning. And can you put the telemetry systems in place to give you feedback mechanisms really quickly about how the model is performing as you expect or not? Now, this sort of notion really resonates a lot with me, because if I go back to the lean startup movement, Eric had this notion of build, measure, learn. And everyone, when they thought about experimentation, was like, oh, I have to build something, then I can measure something, and then I'll learn. But even that notion was incorrect and needs to be unlearned. Now, actually, when we're doing great experimentation, the first thing we should be thinking about is, what do we need to learn? What's our hypothesis? How can we figure out if our idea or our question is correct? And then we do something, we build something and experiment and measure the impact, and then learn again. And this is sort of, again, one of the most interesting patterns, even about starting to think about building machine learning models. You have to start thinking about how can you learn if the model is operating as quickly as you can. So it's not build, measure, learn, it's learn, build, measure. And I think this is, again, one of these subtle parts about much of the learning is going to happen in the market. You're not going to solve all the problems first time. And like all good sort of debates in this space, I once wrote a tweet about this in 2017 about even what great product development was. Product development is not about building products. It's about building the knowledge about the products. And as you improve that knowledge, great products emerge. And I think this is sort of something that really resonates a lot in this space. Again, because one of the things that was a huge insight for me, especially, was the notion that even if you create a great machine learning model, the best case scenario is that it's going to be maybe 60% accurate, and 40% is going to be absolutely useless, or edge cases that it can't solve. Often, again, a misnomer we have when we're trying to build software products is that we can think of all the requirements and get it perfect first time. But best case scenarios for AI is that they can solve a subset of the problems. So you really have to manage the failure modes. limit the blast radius, and again, have early warning systems. So success cases can actually like really wow people. They can blow their mind. But you also have to remember that there are cases that you haven't solved and that actually have poor user experiences and need to be managed. And again, a fun sort of example that most of us, especially during the pandemic, are probably aware of is even Netflix. So the recommendations engine, it might serve up 5 results to you. 3 of them could be great, but 2 are absolutely rubbish. But the interesting psychology part of all this is if the 3 recommendations that are high quality and you instantly love them and like them, your experience as a user is like, wow, this is amazing. But because you sort of miss the sort of parts that aren't so good. So little things to sort of start thinking about. And again, one of the big challenges we've also seen is that these models evolve over time. They're not perfect as they start. And therefore, the danger is we're seeing a lot of businesses, as soon as they see the first outputs from some of these models, they're tightly coupling a lot of their subsystems or value chains to the initial outputs coming from the models. Therefore, when the models improve and want to change, there's sort of reticence to actually adapt your systems because you've tightly coupled them to the original output. And again, this is a massive sort of cost and failure. You need to understand that the models are going to evolve over time. So Bill, you're seeing this like a lot and digging into these types of questions. What are some of the other interesting sort of examples you've seen about this idea of why the telemetry matters from the start, how to manage the sort of 40% of edge cases? What are some of the fun ways that we can create experiences to sort of hide that poor user experience from people, and the favoring adaptability over tightly coupling your subsystems to the outputs that first show up?
Yeah, I mean, I like to use human analogies for learning, just because, especially for people who are new to this, which is most people. Obviously, people who are, maybe they have a PhD in machine learning from Stanford or something can have pretty intricate discussions. But for people who are new to this, who we're trying to help, like the enterprises of the world, just think about learning. So if you go to school for software engineering, the assumption is not that by the end of a trade school or a 4-year college that you know literally everything. The assumption is that by the end of the 4-year college, you know enough to basically start getting the real experience. And then it's a continuous learning journey from there. And so just like it would be ridiculous to expect somebody to go to college and come out with the sort of the seasoning of somebody who might have been a programmer for 20 years, it's also silly to think about that you can train a machine learning model in the lab to a really good extent. And so the better thing is kind of to use that analogy, just train it enough to kind of graduate it. But then the real learning begins in the world, and it's a much richer learning. And it's in fact a much more efficient learning if you've got a solid user base. So that's the way I like to describe it to people.
Yeah, I think this is great, right? And it's even just a general notion I think we all need to let go of, especially in the existing software paradigm, is that we can sort of solve all the problems up front. And whatever we sort of birth or launch into the world is this perfect product, right? Like we see it all the time with 3-year transformation plans where people think that they're going to figure out all the edge cases and scenarios and by just sitting down and writing it down on a plan. But again, I think we've seen with the intervention of years ago in Agile or DevOps and Lean Startup that this notion of doing smaller things and iterating and learning in the market is actually a better system to create great products. And I feel like that notion is really just even more accelerated as we start to look at building better machine models and being aware of the information we're feeding it.
Yeah, and to zoom out from the individual model, where it's also true about sort of needing to learn from experience. If you zoom out and then look at the organization like an enterprise, the enterprise also has to learn about how to bring AI and machine learning to bear on problems, because it's a very different way of solving problems with software than traditional programming. And a common anti-pattern we see, which you were kind of alluding to, is what we call the ERP project mentality, where somebody at the enterprise gets it in their head that we're going to do AI. And the way they do that is by planning a massive project, one massive project that's going to deliver out over the course of 2 years. And then maybe that thing will succeed, maybe it won't. But the much better approach is to basically have a bunch of small projects with kind of more of a near-term outlook, kind of cupcake, birthday cake, wedding cake, so that the organization is learning and have an ability to share with each other, and they're getting much faster feedback as an organization and much faster experience versus the ERP mentality. So it kind of works at different scales, but with similar dynamics.
Yeah, and this reminds me of, like, one of the first sort of projects I got to work on, trying to understand the capabilities of machine learning. It was with a company in the United Kingdom called Just Giving. Their fundraising platform. And they have this wealth of information or data or insights about fundraising. Like when the London Marathon is probably one of the largest fundraising events in the UK, where, and they were always trying to find out, like, how or who is an influencer in this space about how does some person raise like $50,000 and everybody else raises 10? Well, I raise 10 whenever I try to run a type of charity event. But we started with questions, and I think one of the things that's really interesting, and I think a great context to set for listeners, is I often ask, if you could get any answer to help you optimize and run your business, what would be that magic piece of insight or information? And getting people to sort of ask that question is a really powerful way, I find, to start exploring this space and thinking, like, what could be a small little initiative we could do in that space, just like you said, to explore that. And can we answer that? And it's leading with questions. What would we need to learn if we want to find out that answer about why do some people raise way more than others? It's a great framer. And then you can start thinking about, well, if we go and execute and look around some of this information we have, what would be some of the signals that would tell us we're on the right path or not? And I think just this is sort of a little different way for people to start thinking about leveraging this space, is leading with questions. Where would you learn that information before you ever even start building anything? I think it's a nice way to start.
Yeah, definitely. And the other thing to stress is that it ends up being highly iterative, because if you don't come from a background where you basically try to ask the data interesting questions, you don't realize what kinds of questions you can ask. And so, as a concrete example from my background, a few years ago, I was leading the rollout of GitHub Enterprise at IBM to like 100,000 people. And at first, we wanted to just ask a simple question: who's adopting GitHub by business units? And we did that through data insight. So basically correlating activity in the logs with kind of where people reported to in the hierarchy. And then we could answer that question. But once we had that information, then we started thinking about additional questions, like who's, like, not looking at individual people, but kind of trends, like who are using pull requests and code reviews versus just committing to the trunk, which is basically a better practice that you could do with GitHub that you couldn't do with a traditional tool. And anyway, the more you get used to asking questions of the data, the more interesting questions you think of. And so you kind of just almost have to take a leap of faith to start doing that. And then it ends up kind of snowballing with better and better questions.
Awesome. Right. So again, folks, as you're listening, like, drop a couple of questions in the comments to both Bill or I. We'll try and answer a couple of them as we go along. But I think another one of these sort of are two really key notions, I think, that also need to be unlearned is, well, how do you start to execute some of these ideas? And the data, we always hear that the data is such a challenge. So, Bill, could you talk a little bit about some of your insights, again, that sort of need to be unlearned about how we even start to tackle building these types of models?
Yeah, so there's kind of this cliche that data is the fuel of AI, and it's really true, but it's equally true that given current technologies like deep learning technologies, the volume of data to do a good job at training so that the models can be highly performant is just massive. And so if you try to acquire that data through acquisition or anything sort of manual, it ends up just being cost prohibitive. So one of the reasons that companies like the companies who are thought of as leading in AI, especially some consumer companies like Google, Netflix, Facebook, one of the reasons they're so good is that they basically set up a flywheel effect where the millions or hundreds of millions or billions of users interacting with their systems and that instrumentation are basically teaching their machine learning models how to get better, both teaching the models directly and then, of course, the machine learning engineers behind the scenes. And so it ends up just being a lot cheaper. And I think when we get to the error example with Tesla, there's an even kind of easier to grasp example. Yeah, so on this one, I just bought a first Tesla in December and have been really enjoying it, both as a experience, but also kind of learning about the technologies behind the scenes. And so Tesla's kind of further ahead than most car companies are in terms of pseudo self-driving. So you can drive down a highway and it'll do a good job staying between the lanes and staying behind the vehicle in front of you. They've got this really interesting concept, though, that basically every human intervention is treated as an error. And so if you're driving down the highway and all of a sudden you take over, my understanding of how it works is it basically phones home anonymized with the kind of the diagnostics instrumentation about what happened right before you did that, including the sort of the visual recognition of the car. And then that becomes great input to the Tesla human engineers to think about how can we, their basic goal is when we have zero user interventions, then we're done because that means the system's perfect. Now, of course, they'll probably never get there, but that's the kind of basic principle. And if you think about that at scale, especially as more and more people buy Teslas, it just means that they're able to capture more and more errors as input into making the system better at performing that task of staying between the lanes and staying behind the car in front of it.
Yeah, and what I love about this point is it sort of ties it back to one of the opening insights we had, is that putting the telemetry, the analytics, the early warning signals into place before you even start to execute is sort of an imperative, both to understand how the model is operating as you intend and unintend. But, I often say this idea of like, even when you're doing experimentation, failures are gifts. They're signals from your system to say that it's not operating as you expect and opportunities to improve. And yet in so many cultures, we try to hide failures or don't account for them or don't celebrate finding them. But in the sort of interesting part, I think, again, that goes with a lot of this technology is that we want to find the failures as quickly and early as possible because it helps us improve the models. And I think, again, this is a very different sort of mentality that we have often had in the traditional software paradigm. What are some of your other thoughts in that space, Phil?
Yeah, well, I think, again, to use kind of a human analogy, like one way to frame it is around failure. Another way to frame it is just around wanting to have a higher and higher performance. So take an amazing athlete like a Michael Jordan or a Lionel Messi or Roger Federer. Those guys didn't stop practicing when they got in the pros. Michael Jordan famously was the hardest person on the practice court until literally the day he retired. And same thing with Kobe Bryant. And it's because that as good as they are, they understand that there's still opportunities to improve the performance. And so when we think about machine learning systems, whether it's Netflix recommendations, Google search results, Tesla kind of pseudo self-driving car, none of those systems are perfect. And so if you can get in that learning loop where you're looking for deviations from perfect performance, whether it's not slowing down when the Tesla should have slowed down, or Michael Jordan not making as many free throws as he would like, that basically becomes input into deliberate learning to improve your performance. And I think there's some really interesting kind of correlations between, like in human performance, the concept of deliberate practice, or not deliberate learning, deliberate practice from Erickson, and think about instrumenting and having feedback loops in machine learning systems.
Yeah, no, I think these are great examples, and then, I think one many people are probably almost too familiar with these days is also understanding like how to manage that sort of 40% that's not perfect. right? So as we said, AI is typically accurate in the real world, maybe 60% of the scenarios. So how do you manage the rest of that 40? And it's typically by selecting use cases where you can hide that 40%, but still provides a great user experience. And probably one of the classic examples of this is voice interfaces. You know, they may sort of subscribe speech poorly, but the context actually a person can understand what action somebody is trying to do. So when I say, you know, turn off the lights, it mightn't understand me in my fantastic Irish accent. Well, most of the bots didn't at the start, but it can get a sense of the context that I'm in and have some confidence to sort of make some judgment calls, really, and make some bets. So for me, as a sort of user experience, it seems like a wow, but behind the scenes, it's a probabilistic guess based on some of the context of the conversation. So I know you always have lots of fun sort of chatbot examples, Bill. What are one or two that sort of come to mind for you?
Yeah, I've got a really fun fail one with regards to that. So, you know, because I'm a nerd, I've got my house instrumented with smart everything and a lot of smart lights, and I've also got various smart speakers around the house. And sometimes I wake up earlier in the morning, which is when I kind of do my writing and hard work, like 4 a.m. And so maybe a month ago, I woke up early in the morning at about 4 a.m. and said, "Hey, dingus, turn on the lights." And of course, every light in the house went on because I didn't specify, "Hey, dingus, turn on the library lights," because I was tired. I hadn't had coffee yet. So, of course, imagine that if instead of saying that to a Siri speaker or an Alexa speaker, imagine if instead you were in the room with like my 17-year-old son and I said, "Hey, Alexander, turn on the lights." He's not going to run around the house and turn on all the lights. He's going to know that I meant in the room that we're in, turn on the lights. So I think one real shortcoming of a lot of current machine learning systems is they still lack that kind of context that we might call common sense, but might formally been or we could think of as kind of like knowledge of the world and understanding what you really mean versus what you literally say.
Yeah, awesome. So here's one little fun sort of experiment that you can all sort of run even a little bit about trying to test some of this technology. So what I'd love you all to do who are watching along at home is to take out your phone and get the camera ready. And I want you to sort of look at the screen and sort of see if you can scan a dinosaur anywhere on this screen, and just tap your camera to scan that dinosaur. And hopefully it's going to pop up a link actually, which is a chance for you to sort of share with us your feedback. As I said, Bill and I are writing this paper, Machine Unlearning. We're about to publish it in the next week or two. We'd love to hear from you about what would you like to hear in that paper? What would be some of the interesting things that you'd like us to address? As well as share with us some of your feedback on today. You know, what were some of the things that stood out for you? What were helpful? What were fun? How could we sort of make these type of events even better? So just share that little bit of feedback with us on this experiment so we can both learn how we can do this better in the future and also have more fun sort of sharing these things as we go along. So before we then finish up and ask and share any of the resources about where we think is a good place to sow and get started, Bill, what are any sort of common bits of advice you often say to folks? You've mentioned this doing smaller projects to get started. We often hear sometimes that, well, I need a bunch of data scientists before I can even explore this space. Can you share a little bit again what you've learned about what's important about the capability building of this discipline?
Yeah. So the like one view of doing this stuff is that you have to do everything yourself. You have to collect the data, you have to organize the data, and then once you bring it together, you can start iterating with machine learning models on top of it. That's true, and that's one path. But one thing to remember, again, if you're new to this, if you've been around it a while, you've seen this happen. Because of the kind of like the inflection point we hit around 2010 with a number of things kind of converging that we, as Kai-Fu Lee says, emerged from this age of research to this age of implementation, a tremendous ecosystem of toolkits, software libraries, books, Stack Overflow, APIs have emerged that the level of abstraction for doing common things like natural language understanding, speech recognition, visual recognition. There's lots of stuff that you could get started with, even if you don't have a deep data engineering, data science, machine learning capability. So for instance, with the Watson services, about 5 years ago, we started making them available as high quality APIs, where there's there's machine learning models behind those APIs that literally represent hundreds of millions of dollars of investment. But to an application developer who doesn't know anything about creating a machine learning model, it's just an API call. So basically, think of it as sort of like a two-pronged approach. One is where you're creating custom models yourself, and that's where you do need that data engineering, data science, machine learning capability. But the other one is leveraging the ecosystem of toolkits, SDKs, APIs, and that's where you can pretty much piggyback on your existing application development capability. But the key thing is, don't choose one or the other, do both. Understand the custom path will ultimately be more powerful and differentiating, but the kind of the toolkit path will be faster and cheaper and more maintainable. So it's not either or.
Yeah, awesome. Right, so we promised at the start of the show that we would give you some of the sort of tips and books that we've used to help us sort of go on our journey of exploring this space. As Bill sort of said, me personally, I'm very much in my infancy of this trip, but it's been fascinating and has warped my mind and challenged my thinking in many different ways. So again, here's a short sort of set of some recommendations for others. As I said, we're going to be launching this paper in the next couple of weeks. So do please make sure you share some of your feedback both on today and what you'd love to see in that report. Bill, it's been super fun to hang out and do this live stream. If anybody else is so keen to keep going, we're actually going to jump out onto a clubhouse room now and have a little chat in there for half an hour. So if you want to come and join us, jump up on stage, say hello. We'll see you out there. Otherwise, folks, thank you very much for joining. Bill, thank you very much for sharing today.
Thank you. And feedback is very, very welcome.